Hello, Professor Sargent here with you again. We're going to take a look at some application problems that deal with what are sometimes called mixture problems. These two questions, just a little bit of the information could be switched around and the goals reversed. It'd still be very similar problems. In this first one, although they were only asking for how much was loaned at 7%, really you could find out how much was also loaned at 12% to get that total simple interest of $1,165. But I could make this into a question similar to the next one, where we know how much is loaned at either the 7% or the 12%, not both, and then figure out, based on that, how much must have been loaned at the other percentage. I believe I have some similar videos recorded earlier that you may find helpful, and if I can track those down, then you will see probably up above the video a little information symbol and part of the title that you can click on to watch related videos. Before we start solving these, I want to talk a bit about steps for problem solving that come from an author of the last name Polya in his book How to Solve It. And if I recall correctly, he wasn't really addressing algebra questions directly. However, we can take a lot of those ideas. For one thing, he would ask, have you solved a similar problem before? Or is there a formula that you know that could help? And since we're talking about simple interest, we would use the formula that the simple interest added on is equal to principal times rate times time. The principal, or present value, is how much was originally put in. The rate is the rate of interest, and that would have to be changed to a decimal. Time has to be in years. Before going much further, though, you have to realize that whatever we get for our answer, how much was loaned at 7%, it's got to be lower than the $12,000. That $12,000, if we call X the amount, in other words, an amount in dollars loaned at 7%, that and something else totaled up is the $12,000 that was loaned out. You don't have to use this, but you could use a table and we've got 7%, which as a decimal is 0.07. 12% is 0.12 as a decimal. The time is in 1 year. We've named the amount loaned at 7%, the principal, as X. That, along with the 12%, totals up to 12,000. So you would take away the X to find what's left, what remains. That would have to be the starting amount of 12,000 minus what we're taking away, X. There's no guarantee that those two things are the same. We have no guarantee that it's 6,000 and 6,000, as some people try to do. Using the formula, multiplying across, multiplying by 1 is not going to change anything. So the interest from the first account with the lower interest rate is 0.07x, and the interest earned from the one with the greater interest rate is 0.12 times the quantity, 12,000 minus x. So think about what we're told here with simple interest. Notice I didn't write both of those were equal to 1,165. It's the total, which is implying that we have to add. It's a very strong implication. And that sum is $1,165. So distribute off on the side before I pull up a calculator for some other reason. I know that 12 times 12 is 144. 0.12 times 12,000. I can balance this out. If I move this to the right by 2, this would have to balance moving 2 to the left. So that's going to be the same as 12 times 20. Therefore, since 12 times 12 was 144, 12 times 120 is 1,440. Combining the like terms, that's going to make the coefficient of x negative. $14.40. But then when we subtract $14.40 from both sides to get the x term alone, that will also give us something negative. 235, 235, I believe negative 275. And that's an x times the negative 0.05. So when we divide negative 275 by the negative 0.05, those negatives are going to cancel. And that would be the same if I move both to the right now, since I'm dividing the opposite operation. Looks like we're going to have $5,500 at 7%. And since the total that was loaned out was 12,000, that's going to leave us 6,500 being loaned at 12%. And there's our check, plugging into I equals P times R times T. Remember that it was 1 year, so multiplying by the 1 won't change anything. We do get that total of $1,165.